some physical media that Ethernet can run over. Like copper, coaxial cable, HFC, fiber optic, not fiber optic, whatever. Yeah, twisted pair copper wire or fiber optic. 9. HFC, DSL, and FTTH. Not used for residential access. For each of these access technologies, provide a range of transmission rates and comment whether the transmission rate is shared or dedicated. Fuck you. No. 8. Done. Whatever. Each of these R10, R9, HFC, 40 megabits to 1.2 gigabits per second. Download speed and 30 to 100 megabits per second. Upload speed. HFC. DSL super slow. So 24 to 52 megs down. Down. 3.5. 16, not 1.6 megabits per second up. Right. Bandwidth HFC 432.8. Um, 24 downstream. Huh. My wife here. Hello, wife. Most popular. Describe the most popular wireless internet access technologies today. What the fucking Wi-Fi and 5G. Sadie, look at my shirt. I did it last night. Okay. R11. The transmission rates between the sending host and the switch, and between the switch and the receiving host, are R1 and R2. Respectively, assuming that the switch uses store and forward packet switching. I still don't think I gotta throw enough explanation about it. Section 1.3 is supposed to have something here about statistical multiplexing. And this is that fucking n choose m times whatever the probability of n times the probability or 1 minus the probability of 1 minus n, like that kind of thing, which like in simple cases all comes out to just like the intuitive thing to the intuitive power. So I don't really understand what all the other garbage is about, but I'm so hungry. Okay, multiplexing. I see where it's talking about TDM versus FDM. Which is frequency and time division multiplexing. FDM being more difficult to implement. So packet switching is on demand. Circuit switching. There's dedicated bandwidth for each whatever. You know. Okay, come on. Show me. See, in the textbook, it just gives the percentages. You better give me the fucking, because I would need the normal distribution, like, coefficients, to calculate that n choose crap. Because it's just a constant, depending on blah, 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 you know? Anyway, let's get back to it. When circuit switching is used, how many users can be supported? 2 megs, 1 meg each, 2 users, right? B. For the remainder of this problem, suppose packet switching is used. Why would there essentially no queuing delay before the link if 2 or fewer users is there at the same time? That's less than the bandwidth of the thing. If you use 3 or more, you've exceeded the bandwidth. So probability that a given user is transmitting is given. Each user transmits only 20% of the time, so 0.2. And then suppose there are 3 users. Find the probability that at any given time all 3 users are transmitting simultaneously. Find the fraction of time during which the queue grows. So the probability that at any given time all 3 users are transmitting is just 0.2, the odds of any user transmitting to the power of 3. 0.2 times 0.2. The odds of the second one giving the first, odds of the third one giving the first and second. So 0.2 to the 3. And then the fraction of time during which the queue grows is the same as the fraction of time that the odds, like, it's also 0.008. That's the amount of time statistically that the queue would be growing given that all 3 are transmitting. See, this is 3 choose 3 times P3 times 1 minus p. What's 3 choose 3? 1? How do you do Casio FX 300 MS? How to do M choose N? First enter the value of M, then press the shift button, followed by the division symbol key. What? Oops. Oh. NCR. 3 choose 3 is 1. So odds, whatever, so it's odds thing will be N choose M, P, N choose M, times P to the M times 1 minus P to the N minus M. I don't think that's that important. We'll come back to that if we need it. Where's your textbook here? Anyway. Why will two ISPs at the same level of the hierarchy often peer with each other? It's cheaper. Whatever. Okay. Consider sending a packet from a source host to a destination host over a fixed route. List the delay components in the end-to-end delay. So there's processing delay, queuing delay, transmission delay, propagation delay. Processing, queuing, transmission, Jesus, and propagation. And processing delay is fixed, transmission delay is fixed, propagation delay is fixed, and queuing is dependent on what's going down, whether there even is queuing delay or not. Processing delay, transmission delay, propagation, queuing, all these delays are fixed except for the queuing delay, which are variable. Cheers. Visit the transmission versus propagation delay interactive animation at the companion website. I think I'm good. I think I won't do that. How long does it take a packet of length 1000 bytes to propagate over a link of distance 2500 kilometers, propagation speed, and transmission rate? How long doesn't affect, so the length, the packet length doesn't really affect it, unless it's so fucking colossally huge. But it's d distance over speed. Distance over time gives time. So 2500. So 2,500 kilometers is 2,500,000 meters. And we're dealing with 25 million meters per second. So 0.01 seconds. 0.01 seconds. 10 milliseconds. Does this relay depend on packet length? Does this delay depend on transmission rate? But yeah, 25 divided by 2.5 times 10 to the 8, 0.01, which is 10 milliseconds. Right, yeah, no, I was right. Boom. Okay, R19, suppose. Suppose host A wants to send a large file to host B. The path from host A to host B has 3 links. Okay, focus. Host A wants to send a large file to host B. The path from host A to host B is 3 links of rates R1 equals 500 kilobytes per second, R2 is 2 megabytes per second, and R3 is 1 megabytes per second. Assuming no other traffic in the network, what is the throughput of the file transfer? It's the throughput of this file transfer across multiple links is just the throughput, on average, is the throughput of the slowest, or of the bottleneck, which is 500 kilobytes per second. So if it's 4 million bytes, that's 24 million bits, and it's going 500,000 bits per second, so 24 million divided by 500,000, 24 million divided by 500,000, I don't know, I need to calculate. 24 million divided by 500,000, 48. 48 seconds? No, 64 seconds. Okay, hold on. Suppose if what's? Oh no, sorry. It's 32 million divided by 500,000, which is 64. Yes, 64 seconds. Cool. Repeat A and B. No, no. Are you kidding? What are you fucking kidding? R20. Suppose End System A wants to send a large file to End System B at a very high level. Describe how End System A creates packets from the file. When one of these packets arrives to a router, what information in the packet does the router use to determine the link onto which the packet is forwarded? Why is packet switching in the internet analogous to driving from one city to another and asking directions along the way? Oy. Okay. End System A breaks the large file into chunks. It adds a header to each chunk, thereby generating multiple packets from the file. The header in each packet includes the IP address of the destination. The header in each packet includes the IP address of the destination. The packet switch uses the destination IP address in the packet to determine the outgoing link. Asking which road to take is analogous to a packet asking which outgoing link it should be forwarded on, given the packet's destination address. Maybe that was rocky, I don't know. R9, R12. R20. R21. Visit the queuing and loss interaction. I'm good. List 5 tasks that a layer can perform. Is it possible that one or more of these tasks could be performed by 2 or more layers? That a layer can perform? Error control, flow control, segmentation and reassembly, multiplexing, and connection setup. Yes, these tasks can be duplicated at different layers. Hold on. GitHub. Notification. What the hell? Gitbook. Azure pipelines. Now we'll get out of here. Notion. Tickets, yeah. Better results folder. Export permissions. Create a script to export project expiration dates. Export permissions to Excel. Azure Graph Query Virtual Machines. Expired date. Project extension tickets. Script account read deny permissions. So useless shit, really. Yeah, what are the 3 layers in the Internet Protocol stack? 5 layers. Application, transport, network, link, physical. What is an application layer message? Transport layer segment, network layer datagram, link layer frame, data. Good. What's R25? Which layers in the Internet Protocol stack does a router process? The first three. Which layers does a link layer switch process? First two. A host processes all of them. Alright, 3, 2, all. Routers process network, link, and physical. Link layers switches. Anyway, so for R24, where am I? R24. What is an application layer message? Application layer message. Data. Transport layer segment. Encapsulates with transport layer header, network layer datagram, This encapsulates transport layers. Transport layer segment with a network layer with a network layer header. Network layer datagram. Encapsulate transport layer segment with a network layer header. Link layer frame. Link layer frame encapsulates network layer datagram with a link layer header. Okay. Right. Okay, let's take a break, I guess. I don't know, about 15 minutes. 7:32. 7:32. Um, Deck screener chat. Oh my god. Rabbit holing. I'm not fucking paying for this shit. It's $0. What? I'm not paying money for web tools. Are you fucking crazy? Getting overwhelmed. I'm gonna stop looking at that shit. Miss you too, buddy. They need to blow up Snapchat fucking servers and all. Just app is horrible. All right, computer networking. Back to the real thing. Okay. Like what? P such packets back and forth over n links. M plus P minus 1 L over R. What the hell? P3. At a steady rate, I'm thinking circuit switching, which is not on demand. Right? A circuit switch network would be well suited because the application involves long sessions with predictable smooth bandwidth requirements. Since the transmission rate is known and not bursty, that's kind of what I was going for. Yeah. Circuit switching. Only traffic against networks comes from such applications as described above. Furthermore, assume that the sum of the application data rates is less than the capacities of each and every link. Is some form of congestion control needed? So dumb. Okay. Consider the circuit switched network in figure 113. Recall that there are 4 circuits on each link. Label the 4 switches A, B, C, and D and going in the clockwise direction. What is the maximum number of simultaneous connections that could be in progress at any time in this network? Fucking 16, man? I don't know. Yeah, 16. Because it's circuit switching. Set bandwidth, set number of connections. Suppose that all connections between switches A and C, that all connections are between switches A and C. What is the maximum number of simultaneous connections that can be in progress? Passing through the switch in the upper right hand corner and another 4 passing through. 8? Okay. Suppose we want to make 4 connections between switches A and C and another 4 connections between switches B and D. Can we route these calls through the 4 links to accommodate all 8 connections? Yeah, if you fucking crissy-crossy, probably, bro. You got A, B, C, D. You want 4 connections between A and C. There's 2, 3, 4. And then you just do a separate 1, 2, like that. Yes, for the connections between A and C, we route 2 connections through B and 2 connections through D. For the connections 2. Yeah. For the connections between B and D, we route 2 connections through A and 2 connections through C. In this manner, there are at most 4 connections passing through any link. Oh, no, it's not 2, 2. It's just like this. 1, 2. Sure, bro. P4. Come on, P5. Review the car caravan analogy in section 1.4. Assume a propagation speed of 100 kilometers an hour. Suppose the caravan travels 175 kilometers. Okay. Don't make me scroll back up through your textbook to do your shitty questions. Fuck you. God damn it, man. Section 1.4. Scrolling. 10 car caravan. Okay. Suppose 175 kilometers. .75 hours, bro. An hour 45 minutes. Oh god, nowhere near. Oh, you're saying right in front of the tool. Okay. So you go tool booth 1, tool booth 1, tool booth 2, and tool booth 3. These are 100 kilometers apart. Are they not? Okay, so I'm looking at the diagram. Man, I fucking hate this shit. Yo, dog owners, when it comes to like fucking raising their animal properly at all, so that it doesn't become this like disgusting creature that I can hear from inside my house. Shut up.